So the question says to draw a free body diagram of the box. There is friction between the box and the surface, and the box is accelerating down the incline. All right, let's first start with what forces we know that act on objects. We know that there's a weight, it's lowercase w. We know about a friction, so we're going to use a cursive F for friction. And a normal force, looks like a lowercase n with a little tail on it. It's actually the Greek letter eta. Let's see, what else do we know? Oh, if we have ropes or chains or something pulling, tension, and then we have a net force. So whenever something is accelerating, it can have a net force. All right, so we'll go through and we'll look at each one of these forces on our diagram here. So it's called a free body diagram because I don't need to draw the box. I just need to draw the line. I mean the dot. And then I'm going to draw the surface as a dotted line. Not a very good dotted line, but it'll work. So that's this angle right here. That's that incline right there. That's my dotted line. And on my box, let's see, weight. Well, if it's on a planet, it's got weight. So there we go. And weight always goes straight down. So there's the weight. Notice the arrow starts, it touches the actual dot that I've drawn, and the arrow tip is showing the direction that it's pulling. Next, let's see friction. So let's see, there's weight, friction. The only way I know there's friction is if it describes something about it. It says there's friction. Friction always acts parallel to the surface and opposite the direction of motion. Now, it says it's accelerating down the incline, so I know that friction is trying to go up the incline because it's opposite the motion or the intended motion. So there's friction. Normal force occurs wherever there's a surface and the box is on a surface. And normal means 90 degrees, so this force is 90 degrees to the surface. And it's the reaction force. It keeps the box from going into the surface. So there it is. That's the normal force. And tension, well, there's no rope or anything pulling on it, so I don't need to worry about that. Net force, yeah, it's accelerating down the incline, it says. So this is the only vector that doesn't touch the dot. That's the net force. And that's because this isn't a force that acts on the actual box or the body. It's the answer. When you add up all these other forces, you get the F net as the answer. So it always hangs out here kind of in space.